So we had this idea of adaptive parts. If you want one part to always adapt off of another part, then you want to start with an anchor part. In this case, we did the male. And then you want to build the female off of that part, but it has to be within an assembly because you're going to make all the female dimensions reference that male part, no matter what it is. So to do that, we started with a part, and then we went to File, make an assembly from a drawing, or from a part, and then we inserted a new part into that assembly, and that gave us this female. And then we drew the female. In this case, it was a sheet metal part, so it was off. We made a sheet metal base flange, and we started a sketch, and we built that sketch off of this male part. So this male part is here, and the female sketch is here. And then that extruded into this female box. That's a powerful concept. So what I was telling the other group is there may be, you need to, like in software, you need to think of your architecture. There may be, let's say your group has a large assembly with lots of parts, but you want two of them to adapt to each other, but not to adapt to the rest of the parts. In that case, you would make a part, make an assembly from that part, make the second part adapt to that part, and then you can insert that entire two-part assembly into a larger assembly. Okay? We're not doing that here. We're just doing two parts to make an assembly. All right. Where we left off and we didn't finish here was we didn't put the holes in here. So we want screw holes that will mount the female to the male, and we want those screw holes to be on the female and the male part, and we want them to move and adapt with each other. So where do you suppose, if that's the general idea, where do you suppose I should start with holes? The male piece. That's our anchor piece. We want to put holes in the male piece, and we'll just tell the female piece, we'll put holes in the female piece and say, make those holes concentric with wherever the holes are on the male piece. And that way it will always adapt. Now, the problem with that is, so we'll open the male part. We also have to make sure that these holes adapt to changes in the male part, because I may change the height and the width of this male part. We want those holes to always be, I want those holes to always be, I want a hole there and a hole there, and I want them centered on this line at all times, and I want a hole up here that's centered on this line at all times. I want those three holes to always be the same diameter, and I want them to always be the same distance away from each edge. And you notice what I did there? I came up with my design intent, I came up with my architecture for what I'm doing first, and now I can start sketching and figuring that out. All right, so we open our male part. I'm going to sketch holes on this piece. Now I made a mistake the other day, so I'll start drawing these holes. I want to show you the two mistakes I made two mistakes. So I kind of want a hole about there and about there and about there. All right, I made two mistakes. Number one, I looked at this part like this. And I decided to try and relate the centers of these circles to the midpoints of these edges, and that would keep them centered, right? Only problem is I tried to add those relations and make them horizontal relations. That makes sense right here, but what SolidWorks really understands about that face is that it's oriented that direction. So I was SolidWorks wanted to see a vertical relation, not a horizontal one, and it freaked out. And I didn't understand why. So a good rule of thumb is to always use this normal to view orientation, at least when you're adding relations, and that way you and SOLIDWORKS will be on the same page. The second problem I had was, instead of just drawing these circles, when you draw a circle, it pops in a crosshair which represents the center of that circle. Okay? I started by putting a point. Notice the point is a little asterisk-y looking little picture, as opposed to a little crosshair looking little picture. And then I put a circle that was on that point. What that did was that added a relation that made the point that I made coincident with the center of that circle. So I went to go add a relation between this point and this line to make them vertical, this midpoint to make them vertical, and all it did was the point, not the circle itself. So I kind of made that mistake. So don't add points on top of circles of centers unless you're absolutely sure that's what you wanted to do. All right, let's start adding relations to make these circles adaptable based on the rules I want to see. So first of all, I would like the diameter of those circles to be 0.17. And I selected that because that's the diameter that you'd use one of those PEM fasteners to shove into the material. So I want that. Notice that these two are still different. Let's go add a relation that makes the diameter of that circle, the diameter of that circle, and the diameter of that circle equal. Now they're all the same, and if I were to change this dimension, they'll all change to that dimension. All right, next, I want to make sure that these circles here line up with the midpoints of these lines, so that if I change the length of that line, it always stays in the center. So to do that, I'm going to need a point on the midpoint of these lines. All right, and then I'm going to add a relation that says that that midpoint of that line, that center of that circle, that center of that circle, and that midpoint of that line should always be vertically oriented with each other, and see that forces those to be in the center of these lines. All right, same thing here. I want this one, this circle, to be in the center of this line. So I need a midpoint on this line. And then I'll add a relation that makes the center of this circle and that midpoint. Oops. Make sure your selections are the ones you want here. Makes them horizontal. Okay, almost done. The last thing I want is I want to make sure that the distance from this edge to that center is always the same. So I'm going to dimension it to 0.27. Notice that fully defines this arc. And I also want to do that to all of these. 0.27. .27. Okay, now I've got a fully defined sketch, and I can get out of my sketch. I need to cut holes in those circles, so I'll go to Features, Extruded Cut. Let's cut all the way through. And now my male part has holes. I'm going to save that. That should stay centered no matter what we change. So let's change. Let's check that and change this sketch. It's a 10 by 6 box. Let's make it a 7 by 4 box. Notice what happened to the holes. Radically different dimensions on the box. They still stayed centered in these edges. They stayed the same distance away from those edges, and they stayed the same diameter. Questions there? So this is our anchor part. We'll save him. Close him out. We're going to rebuild the assembly, and notice the female box adapted to the male box because that's how we defined it. But the female box doesn't have holes in it. If you were to go open the female box, it has no holes in it. So we want holes in here, but we want those holes to be lined up with the holes in the mailbox at all times. You've got to do that through the assembly because we're on the assembly. Because we're going to relate the locations of those holes to the male part. So I'm going to go to female part and I'm going to edit it. And all I need to do here, since I've already got the anchor part and the anchor part keeps the holes where I want them, all I need to do is make 3 holes on this and then have them be concentric with the holes on the male part. So it appears that the holes are already there, but those holes are not existent in the female part. They're in the male part. So I'm editing. Notice I'm editing the female part. I'm going to go to sketch, and all I need to do is sketch holes into this face. So I'm going to go hole, and for demonstration's sake, I'm going to sketch them in really weird places. So I got 3 circles. I want to dimension them. Let's say I'll make it the same dimension. And I want all 3 to be the same. So I'm going to add a relation that makes the diameters equal. But I'm not going to make any relations with the midpoints of the box. I don't really care. What I care about is that this hole here lines up with this hole here. And that's why we have to do this inside the assembly so that we can reference the male part. We cannot do it outside of the assembly. Alright, so to do that I'm going to add a relation. And I got to be careful to clear all these selections here. I want to add a relation that says that this arc and that arc have to be concentric, and that's going to line them up. Except I'm going to add those same relations to the other 2. I have too many selections here. SolidWorks does that to you a lot. Make sure your selections are clear in your window before you start selecting, or at least go back and look at them. Notice I've got arc 1 in my sketch, edge 2 of Matt General male test. This is on the male part. Concentric. Add a relation. I've still got things selected in the box. Deselect them. Add that arc. Add this arc. Concentric. Should be done. Escape the sketch. done editing the part. I can rebuild the assembly, and my holes line up. There's the male part hole back in here. Here's the female part hole right in there. Now, if all this works, let's hope, we ought to be able to change the male box, and the female box should automatically adapt. This crashed SolidWorks in the last segment, so let's just hope it doesn't. So I go to the male part, go to my base flange and my sketch. I'm going to edit the sketch, which is my length and my width. I'm going to make it, let's say, 12 by 5. Exit the sketch. The female part adapted, and the holes stayed together. Now, that was just the 2 dimensions. If I wanted to change this other dimension, instead of the sketch, I would change the base flange. This was there's my sketch dimension, 5 by 12, and my extrude dimension, which is this way, was 8.5. I could make that 12 as well. Goes farther. Rebuild the part, and the female part adapts, and the holes line up. So I've made an adaptable part for a box, 2 pieces, and if I ever want to change the dimensions, I change 2 dimensions in the sketch and 1 in the flange, and everything just magically lines up. It's a pretty powerful tool. It's cool. Any questions before we leave this? It doesn't just have to be in sheet metal parts, but it's building parts off of other parts within assemblies. I know it's a little bit of a tricky concept, but it's very useful. All right. Wanted to show you another issue. If we, how long do I have here? 10:55? Okay. If I zoom in here, I want to go to a different part. This was another box we made. If I zoom in on the corner here, look at that. What do you see there? Yeah, it's interfering, right? If I take the female part and I change the transparency, I might be able to even see it maybe a little bit better. See that male part hitting that curvature in that female part? And that's just because the sheet metal, as you bend it, it malforms. It's pulling apart like gum. Okay? You would know that. What I want to get at here is, if I'm looking at this and I feel like I'm done with my assembly, it looks like I'm done, but I'm not really done. What you really should get into a habit of, especially if you're making parts that fit together, is going to your interference detection and calculating it. And then you'll see there are several interferences here. I'm going to zoom in on the one that I can see. And it kind of shows you right there. There it is. You can also, if you wanted to get a handle on, well, okay, it's interfering, but how much is it really interfering? Is this really a problem? So what I can do is I can zoom in on my interference. I change the transparency. I'm going to change the transparency of this guy as well. I can go to sketch, put a 3D sketch in, and drop some points where I believe the interferences are. I can go to evaluate and measure the distance between the points. It looks like it's this green one I'm kind of interested in. 0.0176, about 17 or 18 thousandths of an inch. And that equates to a piece of paper is about 3 thousandths of an inch thick. So that equates to about 5 pieces of paper thick, which is like this. So that's not a huge amount. In metalworking, it can be a huge amount. In this particular case, it might not be a huge amount because this male, I kill this 3D sketch that I just made. I'm going to open the male. This male part here is just some kind of thin, flimsy sheet metal. So as we push this up into the female part, these ears, these bends, they're kind of flimsy. They might, in reality, just push in. So this may not be an issue. If this was a solid block of aluminum, definitely an issue. All right, put your thinking caps on. What would be some ways that I could get rid of this interference if I was worried about it? And the very best answer would be one that makes it adaptable every single time, no matter if I change the dimensions of the box. Any ideas? Remember, I defined this female sketch off of this male part. And that's what's really causing the problem here. Let's go back to that female sketch. What dimension or relation is causing the issue? So we're looking at the male part, and we're looking at this female sketch around that part that then becomes the female part. The height, but remember, you're right, it's the height that's causing the problem. So I'd like to just reduce this height by a certain amount. But the problem is, in order to keep it adaptable, this height was not defined. We didn't say, hey, be 5 inches. We said the midpoint of this line needs to be on the midpoint of this line, so that no matter how big the male line gets, the female line will just automatically get that big and the two midpoints will be lined up. So if I just try and hard code the male to be a little shorter, the female's just going to follow it, right? Because its midpoint will stick on its midpoint no matter what you do.
So can we make like 7 point plus 1 and we reduce the height?
You might be able to do that. You might be able to say, here's the midpoint of this line, and here's the midpoint of this line. And instead of them being vertical to each other, I want them to be a certain dimension away from each other. You might be able to do that. That's right. There's an easier way to do it, though. The only dimension we have on this entire outline is here. It's this 0.09. It's this guy here. So let's change him from 0.09 to 0.125 and see what happens. Exit the sketch, exit editing the part. I'm back in the assembly. Rebuild the assembly, and notice what we have here. The little male is tucked underneath, so he's clear. And if we go to interference detection, we have no interferences. So just remember, basically I'm just trying to remind you to check for interferences and then think about that interference and ask yourself, is that going to work for the way I'm going to manufacture this or not? If it's not going to work for the way I'm going to manufacture this, then you need to change your model. If it is going to be okay because it's such a small interference, or for example, we want an interference, we want to press a pin in, then go ahead and leave it. But you'll want to think about that. All right. Any other questions on this before we leave this stuff? Okay, I wanted to move on to starting to look at drawings. Didn't get very far in the last group, but let's give this a shot. So I'm going to open up just this female part. So here's a part, and it's got a drawing already associated with it. Although in this case, I think I'm just going to make a drawing. So let's make a drawing from part. It says there's already a drawing file because I did already have one. Do I want to open the file? No, I want to make a new one. I'm just going to go custom sheet size. It's got my template because I selected my template. Now, for sheet metal, you know, in some cases, you may just want like the isometric view, just so you can see what that box looks like. But for sheet metal in specific, we are very interested in inserting a drawing view from the model. That's this female box. In sheet metal, we're very interested in this flat pattern option. You won't get that on regular parts, but if you have a sheet metal part, that flat pattern option will show up. We're very interested in that because it flattens out our sheet metal box and allows us to potentially cut this out. If we were to print this at a 1-to-1 scale, we could cut this out and tape it to some aluminum and then just go snipping to lines, rather than taking the dimensions here and transferring them onto aluminum with a scribe or something. So that's pretty useful. Also notice on the sheet metal, it drops in the folds. So it says down 90 degrees, radius 0.03. Now that radius will be determined by the type of machine that you have. We typed in 0.03 because our bend radii on our press brakes is approximately 0.03. And I think Professor Hodgkinson even dialed it in closer than that. I think he's got it to like 5/64 or something. But whatever. Anyway, it shows you how to bend these down. Another interesting thing is you can take this drawing view, if you click it, under flat pattern display, you can hit flip view. And if you zoom in and look, now these bends say up, not down. So before this was like this, and when you hit flip view, it did this to it, just flipped it up. That may be helpful. Professor Hodgkinson found that helpful when making the box that you're going to make. What homework is that? Sheet Metal Quiz 4, right? Yep. Sheet Metal Quiz 4, which is due Wednesday. So you're going to actually take the piece of aluminum metal. Did you guys get that? You guys got that, right?
Yeah. Mm-hmm.
And you're going to print this, what the box I had you made, to 1-to-1 scale, tape it to that aluminum, snip it out, and fold it up. All right. So this may be helpful to flip this view. You'll have to decide. What I strongly encourage you to do is to, and I'm probably going to reiterate this to the other group, what I strongly encourage you to do is print this out, tape it on there, and look at it, and think through your process before you go snipping and folding. Okay? Think through the steps one by one and make sure that you think you can do it. Go to the machine, look at the machine, pretend to stick it in there and pretend to bend it and say, okay, is that going to work? If I make this fold, can I then make that fold? And then one other hint, when you go to punch holes, if you're punching them right next to an edge, you can malform the material pretty easily. So if you have this big piece of material, you might want to punch the hole first before you go and snip the edge, because then you'll have more material to distribute the load over, and that punch won't, when that punch comes down, instead of bending the material, it'll actually punch it. I should probably remind the other group about that too, to be fair. All right, before we move on, if this thing was bigger or such that you could not print it out 1-to-1 scale and tape it to aluminum and then start punching, you might have to put dimensions on for the machinist so that the machinist can then go to, let's say, this big piece of sheet metal and draw this thing on. So you might want to have to start dimensioning this. This goes into our drawings lecture. We could dimension, let's say, from there to there. So there's a dimension. And we could dimension from there to the center of this circle. And then we could dimension from there to the fold. And we could do from there to the center of the circle. And from there to the fold. Notice how busy and ugly this is getting pretty quickly. All right, I want to introduce you to Ordinate Dimensions. So I'm going to delete these. And you saw some of this when you were walking in. But you can go to Smart Dimension, and instead of doing Smart Dimension, you can do Ordinate Dimensions. And what this does is it picks a coordinate, so let's say here, and makes that 0. And then when you click other items, it puts a dimension off that 0. So then I can do that edge, this center, and this one. So that kind of cleans drawings up. And really you use these when you have a bunch of dimensions that come off of one edge. You wouldn't use a dimension like that for, say, the circles, because you want the diameter of those circles to be a diameter, not an ordinate dimension. But those ordinate dimensions are pretty cool. I don't see them a lot on people's drawings. Okay. That's about where we were. I have more, but I want to stay current with the other group. So let's go ahead and go to break early.